Today we will be adding and subtracting fractions that have unlike denominators. So we're looking at adding, subtracting, multiplying, and dividing, but right now we're adding and subtracting fractions, and today's goal is to specifically look at ones that have unlike denominators. And look at the standard's still the same as yesterday. So you should have your vocabulary page already filled in, so you don't have to do any more work on here. The biggest thing you want to notice is that we have to find a common denominator today. And today we won't already have that. So you're going to need to find a common denominator. And to do that, you'll have to multiply by a form of 1, like 4 over 4. Remember still, we're adding or subtracting depending on what the signs are. And we're always, for subtraction, doing stay, change first. All right, so to add and subtract unlike fractions, first you need to remember that unlike fractions are fractions that do not have the same denominator. And the denominator is the bottom number. So notice here, these are unlike fractions. 2/3, those are bigger pieces. 1/4 is a smaller piece, and they do not have the same number. This 3 is not the same as 4. So to find a common denominator, first you need to remember what the least common multiple was, LCM, which is the same as finding the least common denominator. So if I have numbers 2 and 3, I might list out possibilities, and maybe this is what you did last year. Oops. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and so on. And you could just list them like this, or you could also make them, we're going to make them in tables later. Okay, and 3 has to be 3, 6, 9, 12. This is like skip counting. These are also found on your multiplication table. So if you still have that purple sheet of paper that has all the multiplication tables on it, you would be able to look on there as well. So now, to find the least common, we want to find the smallest number that's the same. 2 and 3 aren't the same, 4 is not the same, but 6 and 6 are the same. So the least common multiple would be 6. And what we're going to look at today is you're going to look at a table and you're going to try to put 2 into 6. Let's say we have 1/2. That would be 3/6, because we're going to see that we multiply by 3 and multiply by 3. And to put thirds, let's say we have 1/3, you're going to put that into a table as well. And so we're going to have a 6 on the bottom, because we know that's our least common multiple. And so then 3 times 2 would be 6. And 1 times 2, this time we're multiplying by 2, is 2. So now we have 3/6 and 2/6, which is going to help us. We have to have the same size pieces in order to add fractions. Otherwise, someone's going to get mad. All right, 1/2 plus 1/6. Let's try this problem. So, unlike fractions, because they both have a different denominator, you already know that, but now we need to get them to have a common denominator. So what I'm going to have you guys try this year is using a table. We're going to put 1/2 in one of the tables, and we're going to have 1/6 in the other table. If you'd like a pre-printed sheet of this, you can look on my class documents on my website to find that. If you have any trouble, just let me know and I can send you the link, or I can just send you the document. But I have a pre-printed one that already has all of these fractions already on tables. And this is going to help us. So I'm going to show you that page right now. If you'd rather just keep writing on a separate sheet of paper with this, that will work as well. So here's the worksheet, what it looks like. And this is just with positive numbers, because once you understand how to do it, then you can apply it to negatives. But it might be good to first make sure you know how to do it with positive numbers. Okay, so we have 1/2 plus 1/6. That's the problem I just had. And we're going to put tables on there. And notice I started this one already. 1/2 would be the same as 2/4. You can also look at this on your multiplication tables. And basically this is just one line, and this is another line of that multiplication table. So notice on the top we're going by 1s, and on the bottom we're going by 2s, 2, 4, 6. It's important that you go by the same number you start with. So for example, if I start with 1/6, the top always is going to go by 1s. It's like doing 1 times 2 is 2, 1 times 3 is 3. 1 times 4 would be 4. 1 times 5 would be 5. And then the bottom number would be going by sixes. 6, 12, 18. So you're skip counting, basically. Or you're also multiplying. So 6 times 2, 6 times 3, 6 times 4 would be 24. Now, you may be asking yourself, why on earth, Miss Sandin, are you even doing that? Because we already have 6 here. Well, you're right. You don't need to in this case. I just wanted to show you so that you'd be familiar with it for future problems. So this right here, this is 3 6. And notice we're looking for where are the bottom numbers the same. So 3 6 is already the same as 1 6. We don't need to go any further. We just need them to have the same size pieces. Once they have the same size pieces, you keep that denominator the same. You never add denominators. We never add and say 1 6 plus another 6 would be a 2 12ths. That doesn't make any sense. That's not going to work. So instead, we keep the same size pieces. So it has to stay 6. And we add the numerators. 3 plus 1 is 4. Then don't forget to simplify. Always put answers in lowest terms or simplify. So divide by 2, divide by 2. 4 divided by 2 is 2. And 6 divided by 2 is 3. So our answer is 2/3. If you already knew that, awesome job. Keep up the great work. And so this is, with it all filled out, the same idea, 2/3. But we don't have to complete it because we already see the common denominator. If you notice, you could have also done 12ths, but then you'd have to simplify. So that's why it's good to do the least common denominator, the red, okay? Otherwise, you're gonna have to simplify more when you're at the end. All right, so let's look at another problem. It's actually at the back of the back page, or sorry, at the bottom of the back page. We're gonna look at number 12, just because it's got mixed numbers, and I think that'll help us. If you want, you could change these to negatives, so you could try practicing something that's more for this unit. And then basically just remember, a negative plus a negative is more negative. So really it's the same problem. You might be asking yourself, Miss Sandin, how do I fill these boxes in if I've got a mixed number? Well, you don't. You first have to change all mixed numbers to improper fractions. So please remember that. That's the same for all of these operations. It just works a lot nicer if you remember to do that. So we're going to do 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5, so I write the 5 on top. And the 2, the denominator stays the same. That's the 5/2. And these are negative, so if you want to write a negative sign, you can there, but that doesn't change anything except that the answer has to be negative. 2 3/5 I need to do again, multiply and add, so I've got 13 over 5. And again, you can just make these on a paper very easily with a T going sideways. Okay, so now I need a common denominator between 5 and 2. If you want, you can go by 5s up here and go by 2s on the bottom. And you can fill all of these in if that's easier for you. If you're a person that's like, Miss Sandin, that's way too much work, then you don't have to do that. Just make sure that you get to the right number that you need. So if I look at 2 and 5 and I know, oh wait, I need it to be in tenths, then this one you can stop. All I did was I added 13 and I added 5. And for this one, you have to make sure you get to tenths. Okay, so once I have a common denominator, these are my fractions. I've got 25 over 10, so I'm going to keep that here. And then I have 26 over 10, and these are both negative, so I have to add them together. Make sure you remember that. So 25 and 26 is 51, stays negative, over 10, but I can't leave it like that. I have to simplify. I'm going to get it wrong unless I simplify. So this is negative 5 because 10 goes into 51 5 times with 1 left over, and that would be 1/10. All right, so negative 5 and 1/10 would be my final answer. Don't forget to go back and make sure it makes sense. If this is about 2 1/2 plus 2 3/5, wouldn't that be about 5? That would make sense to me. And because they're both negative, the answer has to be negative. Always go back and check your sign. So do you see the steps? Change to improper, then get a common denominator, then add the numerators or subtract depending on the problem, keep the denominator the same, and then simplify. Go back and check your sign. If you're feeling like I'm talking too fast, remember you have these in your notes already. So you can just look at your note. I'm just gonna check my answer and make sure that I got the same answer I got before. All right, awesome. Looking awesome. All right, your turn. Try this. 5/9 plus a -1/6. Be careful, these are different signs, so you need to subtract. Okay, so now my turn. I'm gonna try to do this and see if it matches what you had. I can't add these until I have a common denominator. So I'm gonna use the method where I have tables. If you'd rather do it a different way, that's totally fine. So I do 5/9 here, and I do 1/6 here. I need a common denominator, so I need 9 and 6 to go into the same number. If I go all the way up, it's gonna take quite a while. So I'm gonna think instead, okay, 18, 6 goes into 18, and so does 9. So I'm just gonna skip right away and multiply by 3 here. Again, if this confuses you, go back to the one that has all the steps. So times 3, 3 times 1 is 3 right here. And this, I just added 9, so I have to add 5 here, or double it, whichever way you want to see. Again, if this confuses you, just do it the way you're used to, as long as it works, okay? So I have 10/18, and I have to add a -3/18. I hope you can see this okay. So now I have 10 plus a negative. That means these are different signs and I have to subtract. So 10 minus 3 is 7. 18ths. I can't simplify that, so that is my final answer. Check my sign though. It's positive. That makes sense. Yay! Okay, to subtract, remember, stay, change, change. So if you want to write this one down the way it was before, it was -3/4 minus 5/6. That problem, let me try black, becomes -3/4 plus a -5/6. And now I have the same signs, so I add and keep. I cannot add though until I have a common denominator. Do not start adding these without changing them to a common denominator, or you will be very sad because you will get the wrong answer every time. Okay, so I have 3/4. I need to change it into the same denominator. I know that 4 goes into 12 and so does 6. So I'm going to go right to 12. If I multiply by 3, I can multiply this by 3. 3 times 3 is 9. So I've got 9/12. And then this one, I can just double, and then I can double this. I've got 10/12. All right, so I'm going back over here. I have -9/12, and then plus a -10/12. All I'm doing is replacing these fractions with ones that have a common denominator. Now, I can do the numerators. -9 plus 10 is -19. I'll write that over here. And I keep the denominator the same. Don't you dare add those. Okay, now 12 goes into 19 one time with 7 left over. I hope I did that right. Let's see. 9 minus 2 is 7. Okay, but it has to be negative, and I have to make sure my answer makes sense being negative. Yep, I've got about 1 plus about 1, so this should be about 2, but it's got to be negative. All right. Your turn. 4/5 minus -1/3. Stay, change, change. All right, so let's check and see how you did. Stay, change, change. That's like adding, but I need a common denominator. So 4/5 and 1/3. Okay, 5 goes into 15 3 times, so I have to multiply this by 3. Whatever I do to the top, I have to do the bottom. 3 goes into 15 5 times, so I have to multiply by 5 on the top. Okay, and then I have 12/15 plus 5/15. That is a total. We add the top numbers. That's 17/15. And then I divide to figure out how many times 15 goes into 17. It goes in one time with 2 left over. Yay! That is my final answer. And it's positive because both of these, once we did stay, change, change, became positive. Nice job if you got that right. All right, one more. For this measurement problem, Ned pours 7 2/5 ounces of water from a beaker containing 10 1/4 ounces. How much water is left in the beaker? So we're starting with a big amount and we're pouring some out. Hopefully you did well. Let's see. So I have 10 and 1/4, and I'm subtracting 7 and 2/5. I cannot subtract until I have a common denominator. So I'm going to put that over here, just right here. So I have 10 and 1/4. I have to multiply and then add. Please don't try shortcuts. They really can make things difficult. So instead, multiply and then add. Some people asked, can I just leave them as whole numbers? Well, no, because if you do 10 minus 7, you'll get 3, but then 1/4 does not subtract 2/5. You can't subtract those. So I really would recommend using improper fractions. 37 over 5. They give you big numbers, but you will get fewer problems wrong. All right, so now we need 4 and 5 to go into the same number. I'm thinking 20 because I'm thinking in my head 4, 8, 12, 16. I'm going to go all the way to 20, and then 5 can go into 20 as well, 4 times. Okay, so if I multiply the bottom by 4, I have to multiply the top by 4. 37 times 4 I can't do in my head, so I'm going to do that over here. 28, 12 plus 2 is 14, so 148. I can always check with the calculator, but please try to do it by yourself without checking first. Okay, times 5. I have to multiply this by 5. I knew that because 20 divided by 4 was 5. So 41 times 5. Let's do that over here. 41 times 5 is 5. And then 20, 205. Does that make sense? I think it does. Okay, so now I've got two fractions that have a common denominator. Maybe I should have done that in a different color, sorry. Let's try this, okay? And then I just need to figure out, am I going to subtract or add? Well, in this case, subtract. So I do 205 minus 148. Let's move this out of the way. I get to do that. You get to just find another spot on your paper. Okay, I'm going to move these up a little bit so we have a little more space. Okay, here we go. We're going to go back to black, back in black. 205 minus, over 20, minus 148 over 20. We can do this. Keep the denominator 20ths, and then do 205 minus 148. So 205 minus 148. I can't subtract. 5 minus 8 does not work. So I have to borrow. I can't borrow from here, so I have to borrow from here. Remember, a lot of you have had trouble with this borrowing thing. Keep borrowing as long as you need to. 15 minus 8 is 7. 9 minus 4 is 5. And this would be 0. So 57 over 20 is how much is left in my beaker. That doesn't make any sense. So I have to long divide and figure out 20 goes into 57 2 times. So that would be 2 with 17 left over. And again, if you can't do that in your head, do it over here. 57 divided by 20. Some of you are flipping those and trying the other way. That won't work. So 20 doesn't go into 5. 20 goes in here 2 times. And this is what I'm doing in my head. If you can't do that in your head, no worries. Just do it on paper. And then don't forget to label it. It's in ounces. So how much water is left? All right. 2 and 17/20 ounces. There we go. We did a word problem. Yay! So, this is what your homework might look like. You might have to use 2 boxes for the same problem in tonight's homework. So I just gave an example. These first 2 boxes could be problem 1. The next 2 boxes could be problem 2. Or if you want to use loose leaf, you can totally use loose leaf. Notice this right here is where I meant for you to write out the problem numbers that you need to do. So like, I'm not sure exactly what the problem should be, but let's say it's like 12 through 30 evens or something. Then that would go there. Okay, don't quote me on that though. That might not be right. If you have questions, let me know. Write a question. And this is Mrs. Sandin, and I am out.